Okay guys, I wanted to talk to you today about preparing the soil and soil fertility. So one of the things we need to talk about is plant varieties. And so if we're talking about gardens, we need to know, are these perennial plants or are these annual plants? Are they going to live one season? Are they deep rooted? Are they very shallow rooted? It's very important because if we're deciding about cultivation and tilling and getting nutrients down in the soil and watering and all of that that goes along with what type of plant. So knowing your variety is super important. So the seasonality of it is of extreme importance. The days that it takes to maturity is also very important for plant varieties. Again, we're trying to fit these things into our season. Preparing the soil fertility. So what Rich and I have been doing is prepping the garden area for the pumpkins. This is a brand new area. At YC, we have field growing conditions. We have brand new field growing conditions that I'm going to show you through pictures. We also have raised beds, which are just filled with really good soil. Those raised beds are in a straw bale perimeter with soil inside, and we did like a layered lasagna garden with red wigglers. And so in the raised gardens, we have our own YC compost. We have manure from a local farm, a horse farm. We have peat moss, we have mulches, we have composted paper materials. We have one year we used all the green weeds that were out there. They didn't have seed heads on them, so we cut the green as a green layer. We layered the worms from our vermicomposting in there with shredded paper, and then we added compost on top, and then we added a layer of mulch on top of that to kind of cap off any seeds and weed material that was down in there. So we do till, we do no-till, we do containers, gardens, we do hydroponics completely without soil. So there's a little something for everyone, but I think most people, when they think about the subject, they're thinking about preparing new soil or working in existing garden beds. So that importance of till versus no-till, there's a lot of areas of the country that are really big proponents of no-till. That's coming more so from big ag, that we're trying to get big ag to do no-till so that there's not a lot of erosion, both wind-blown and water erosion. One of the issues with no-till in our area is my opinion is that unless you live in just gorgeous soft soil, there's no real way to get the nutrients down in. So if you're trying to use a no-till approach along with organic practices, you can't just put the material on the surface when you're adding the amendments, even if they're organic. You can't just put them on the surface and expect the plant roots to get them. They have to be incorporated into the soil. And so in my own home personal garden, I tilled deeply, and I tilled in a lot of manures and composts and some initial nutrients that were lacking in my soil. And then from that point forward, I can do a lot of no-till. You can even cover your rows with mulches and stuff, which we'll talk about, and it makes it even more conducive for stopping erosion and those types of things. So if you're gonna till, again, we're at the college, so we have access to a tractor when we have wide open area. So the area I'm showing you, we moved the compost over and we tilled with a tractor attachment. That's really, really helpful. It saves your back. We also have a smaller tiller, and they even have little hand cultivators now, both manual that you can push or hand cultivators that have a small engine attached to them, and they would maybe just be tilthing the soil or tilling, just a few inches deep. There is also, I'm all for horticultural exercise. There is also the aspect of hand digging, and there's many practices like double digging or hand digging and using big spades and lifting. There's tools made for this. You can just use pitchforks or round points, but there are tools made for lifting the soil and digging. Now, size is important. If Rich and I were going to plant 300 pumpkin plants out in the field setting, it's scalable, it's sizable. If we were doing 20 feet, we could hand dig that, no problem. We could probably hand dig that by the time we could get the tractor out and get the attachment on. As you start to get bigger in size, if you start to think about small market garden or a horticultural endeavor, you're going to need some implements just because of the reality of doing those things. But for a backyard garden, whenever I say till, you can till your soil and loosen your soil by just getting after it manually. Organic addition is very important. So regionally, here in the Southwest, there are some materials like forest byproducts are readily available. We have a lot of horse industry here. We have dairy farms here. It's easy to get those type of organic materials. Peat moss is readily available because it's readily available across the country. Those are examples of organic material. So our soil is made up of components of sand, silt, and clay, possibly some organic material, usually not very much, and then obviously rock in various forms and degree. Having rock in your soil isn't bad unless you have boulders in your soil and it's actually not soil and it's taking up so much space, there's no place for plants to grow. But if there's soil surrounding rock or gravel, it can become usable. Regardless of whether you have sand, silt, or clay, the addition of organic material would help to hold moisture. If you have a well-draining soil that's a heavy, like a lot of sand in it, adding organic material will hold moisture better and make that soil better. If you have a heavy clay soil that just holds water and becomes waterlogged and soggy, adding organic material will help loosen up and add some oxygenation, some air, pore space in those soils to help water drain better. So again, plan on using organic material, and it doesn't have to be an all at once type of thing. You can add over years and years and make this a long-term plan. It's not going to be perfect in year one. We're taking typically poor soil and we're trying to make it better every year. And we're amending as needed yearly. Making your own compost is a great, easy thing to do. Remember, 50-50 with carbon to nitrogen, and that would be like carbon would be straw or leaves typically, or small sticks that are chopped up really small, or chippings or shavings or bark, corn stalks. The green material would be leaves. That would be a nitrogen source. Grass clippings are common. Green manures that you could collect or grow yourself. And so when you have those in a relationship, add the right amount of moisture and add oxygenation and turn that pile, you'll make compost, and then that compost could be used back into the garden. If you're putting things with weeds or weed seeds in them, you have to be very careful that they're not pernicious, because a lot of things will go through that composting process, because even if you heat up the center of the pile, there's always an edge to the pile. So if you're turning, there may be the opportunity for something to move through that pile. So I like to keep things that maybe spread through rhizomes, really bad weeds or weed seeds that are really hard coated, shouldn't go into the compost. I highly recommend a soil analysis. If you're doing anything on a larger scale and can justify the price of $50, $60, $70 for a soil analysis, we have some companies we use. The universities have them. There's places, IAS in Phoenix, MOTS in Phoenix. There's laboratories in the Midwest. So they're out there, and I will, if you email me, I'll tell you who we utilize and such. But and we've used different ones. We'd like to stay consistent so that we're not constantly seeking out a new recommendation or a new theory or a model. And we'd like to use regional or local for areas that are already dealing with the types of conditions we have. They're used to making recommendations, and so I highly recommend at least starting with someone in Arizona if you have that ability. So a soil analysis will help you with the pH. The pH is very important to know because it dictates nutrient availability. I'm doing this with my hands because as you get higher in pH, some nutrients become unavailable, and if you get too low in pH, some nutrients become unavailable. There's a range in the middle that's best for most nutrients, but within that range, there's different availabilities. So typically, and this is the tricky part, typically our soils and our water mirror each other in pH. Here at the campus, we're above an 8.0. At the Verde Clarkdale campus where I teach horticulture, we were like 8.2, 8.3, 8.4. Being 7 on a pH scale or higher means you're very alkaline. 6, 6.5 for most agronomic crops. If you're between 5.5 and 7, you're pretty much okay. You don't have to do anything. The extreme would be you're growing azaleas and blueberries, which you're probably not because of the the alkalinity of your soil, but if you wanted to, you would really have to acidify in some way because we just don't have it. If you were too acidic, you would use products like lime to raise the pH. So don't ever use lime unless you got a soil report that says your pH is low. Trust me, I've studied many, many soils across Arizona. There are very few cases where the pH is low. So if you go to your garden center and buy lime because you read a report from Maine that said you have to lime your soil, that's not for our soil. We use something different. We use soil sulfur to drive the pH down. In the greenhouse or in horticulture ventures, they actually can add different acids to waters to move the acidity and to make it more into the neutral range. When you use products like soil sulfur in a soil-based growing situation, those soil sulfur pellets, it's elemental sulfur. It gets down in the soil, you work it into the soil because it can't just be on the surface, and as that elemental soil sulfur breaks down, it turns into sulfuric acid, which acidifies that sphere around that pellet. And so you have to use a lot of it, and it does add sulfur to your soil, and sulfur can be usable for plants. It can be necessary for plants. You have to be careful because if you use sulfur over and over and over again, you might need to get a soil report that tells you if your sulfur is in an okay range to keep adding sulfuric acid. A lot of products are neutral. They won't do anything with the pH. And so you can drive down the pH of your soil, but what happens every time you water? Especially if you're on a well where that water is a reflection of what the parent material is from above or wherever that water came from, you're still just dealing with very alkaline water. And people may say, "Oh, I'll do reverse osmosis. I'll improve my water." The easiest thing to do is acidify. Think about the gallonages you would be using for a typical garden or a small horticulture production, and you'd start to see that acidifying is the best route. EC is electroconductivity, and I did show you a video in the last couple of weeks of a student measuring nutrients in a can. It's just a good old-fashioned way of saying, I got to get some nutrients to the plant. I can't wait forever. I'm going to mix up elemental salts and use an EC meter to tell what the electroconductivity is. And so we call it the EC, and it's a good way to know how much salts or nutrients are in a solution. That could be a solution derived from the soil. You can have it leach through the soil and then collect and measure the salts, or you can mix up a watering can or an injector system to send nutrients out and know what the EC is. Deficiencies in your soil can be shown in the plant growth, and you can fix them the next year or you can fix them during the growing season. But if you're doing cultivating, the best time to do that for the garden is get the nutrients needed in before you plant. That way it can be incorporated into the soil down where the roots need it most. You can do applications through incorporation, through injection, or through foliar spray if there's a specific micronutrient that's tied up in the soil. Oftentimes things like zinc or iron, it just can't be released in the soil no matter how much you acidify. It's too alkaline, and so a plant showing iron chlorosis just can't get iron up into the plant. There could be almost toxic levels of iron in the soil. So if you did a soil test, it would show there's adequate iron. The problem is if the company that's analyzing doesn't know your high pH is locking up that iron, then the plant is going to be suffering from lack of iron while growing in an iron-rich area. And so foliar applications can work as an immediate fix. And so a lot of crops get seasonal iron applications to avoid, if you're growing an annual crop and you're trying to put down some kind of iron product, or you're like, I'm going to put copper pennies in the soil, or I'm going to put iron nails in the soil, or I'm going to think about how long it takes to break that down, and it's not good to do that after the fact. That's like building for the future type of thing. So incorporating into the soil, injecting through an injection system, or foliar spray out over the top. And the foliar can also be fish emulsion or other liquid nutrients that could be applied to the top. And so deficiencies during the season can be checked through tissue analysis. So you can actually take a petiole from the leaf from a specific area, and there's recommendations of during wet growing stage how much nutrition should be in that petiole, and if it's not there, a recommendation could come back for what you could fix immediately or how you can fix it for the next year. And again, you have 3 ways to fix it: incorporate, inject, or foliar application. So that being able to test your soil and being able to test your water and then being able to look at a petiole analysis and know what the plant is actually taking up is a good way to triangulate and become the best knowledgeable grower you have. The other thing you have as a grower is just to look at the plant, look for deficiencies. Is there yellowing? Is there veins green, or the veination, is it yellow? Is there a purplish color? There's many things that a plant will show you about deficiencies or potentially toxicities that you don't need a soil report to know or to see. The other thing is keeping in mind how long your crop will live in that setup. Are you going to grow for a season and then get it out and then follow it with another crop? Crop rotations are really good. And is it a 2-3 month crop? Like, is it radishes and it's going to be done in 40 days? Or is it an onion that's going to take from seed all 110 to 120 days? Or a sweet potato that's going to take your whole warm season and pull tons of nutrition out of the soil? Is it going to be deep rooted or shallow rooted? Those are very important. And so also your crops that you're growing, you need to know and think about the implication of growing hybrids. So these are seeds where they take, these are seed companies grow parent plants in fields, they research them, and they find crosses that when parent A plus parent B are bred together in a controlled cross, it comes out with the F1 generation, which an F1 hybrid seed then is your named seed variety. That'll say a named seed on the packet. Hybrids are good because they're tried and true. Always when you cross this and this, you get the F1 generation. And so it's a way with seeds of minimizing the genetic variability and makes the variability very specific. And so if you're growing pumpkins and you want a variety that has some powdery mildew resistance, you can buy a hybrid that's been tested to have resistance to powdery mildew. Heirlooms, I'm a big proponent for heirlooms as well, because heirlooms are seeds of plants that are tried and true in an area over time, and then they're spread wherever seeds can go, will travel. And so heirlooms usually have a long time, a long history. They're usually regionally developed, and they come true to type. The problem with true to type is plants within the same genus can pollinate with each other. So if I have a Hopi, blue corn and a some kind of heirloom yellow corn, and I grow them in the same area, the Hopi blue corn will have blue, and the sweet corn will have yellow. But when I save the seeds and plant them out again the next year, my heirloom will have shared genetics and will come up with something quite different. And so when you're growing heirlooms, you kind of want to keep them separated a little bit so they're not pollinating with each other. And so you got to be careful with squashes and cucurbits. You can have a funky, crazy pumpkin, and it's not the first season. It's the second season after saving your seeds. But I'm all for saving your seeds. It gives you control, gives you local control. There's enough hybrids being bought every year, and there's enough reasons to buy hybrids, special circumstances. We buy hybrid seeds for our greenhouse tomatoes that are developed and bred specifically to grow well in those conditions and to grow more upright and to minimize side branching for uniformity. But there's plenty of good reasons, especially for backyard gardeners, to utilize heirlooms. The last classification would be some kind of genetically modified seed, which is interesting and very scientific as well. We won't get into all the aspects of that. It's been a very hot button topic, but what genetic modification is, other than just specific human natural intervention with genetic modification, would be to actually take genes out of one seed, isolate those, cut them, and put them into another type of seed, then grow that seed out that has a characteristic that wasn't natural to it. That can be good. That can add different proteins or nutrition or different traits that could be, and the benefit could be good. It can also kind of go sideways on us. It could introduce things that really shouldn't belong. And so I'll let you guys decide on that. But science is super amazing. So just to recap, prepare your soil, add nutrition, make a plan for how you're going to water. We'll talk more about that coming up. But utilize soil sulfur for lowering the pH down into the acceptable range. Think about nitrogen, phosphorus, potassium. Nitrogen is typically the limiting factor in growing in Arizona, but you can't just add nitrogen. Nitrogen on a fertilizer bag is the N. There's N, P, K, and micronutrients. That's nitrogen, phosphorus, potassium. If you just add nitrogen, I'll grow pumpkins with huge, long, greenish growing plants I've ever grown ever, and the pumpkins will be very minimal. It won't flower as much. It'll just grow and grow and grow green. So nitrogen for green growth, phosphorus is roots, fruits, and flowers, and potassium is for strength and vigor. Again, most soils in Arizona have adequate potassium, but how do you know without a soil analysis? They make little home kits that you can buy at your local stores where you mix up a solution and you look at the card. I'll tell you what it's going to say. I'll save you the $5. It's going to say you're lacking in nitrogen. It's typically going to say you're lacking in phosphorus, and it's typically going to say you're adequate in potassium. And so we like to work on that premise, and my basic recommendation is to add complete nutrition, favoring the nitrogen. And if you're growing a fruiting and flowering, heavily fruiting and flowering crop, think about getting your phosphorus numbers up. If you just added nitrogen and you were growing a tomato, super tall green plant. If you just added phosphorus, you'd have a stubby little plant with big, huge fruit on them. And a lot of times you see phosphorus on super flowering type things. You want the plant to just flower, flower, flower. It's usually fed something high in phosphorus. If you're at the store and you're looking for tomato food and pumpkin food, and you're looking for tree food and vine food and flower food, just remember to look for the three numbers. The three numbers indicate what it is that you're growing. The three numbers will help you make a decision about why to use those nutrients. So nitrogen is a limiting factor. We use nitrogen, and it's usually expressed in pounds per acre. Utilize incorporation, injection, or foliar, and we utilize at the college all of those tools. We don't eliminate any opportunity to do anything to get nutrients down. And then pH, know your pH. It's important, and it's probably high, so you got to find a way to drive it down. And then add organic material, whatever you can find, but make sure if you're going to get horse manure and it's fresh, Bermuda grass seed is going to come through if they've fed Bermuda. Or what the bedding is. You got to make sure that that seed doesn't come through. That's why I recommend composting if you're getting horse manure or organic material that's a byproduct type of thing. Okay, so good luck and get planting.